Okay, so this is practice test 1. Hope you guys are doing great, having a good day. Obviously, by now I'm missing you. I have some guests in the room. They are working along the practice test with us. So if you hear some noise, it's just them getting all excited because they're getting to do Precal today. All right, so problem number 1. We are going to sketch and fill in all the information for this rational function. So everybody knows how to start. I bet even our visitors know how to start. We need to factor it. So we're going to factor our problem. So the numerator factors as x, everybody see it? Minus
2.
Actually, it's going to be plus 2 minus 3 because we need that to be negative. So that gives us a 2x minus 3x. So that would be a negative 1x there in the middle. And then on the bottom, that's the difference of squares. So that will be x plus 2, x minus 2. Now remember, everybody's writing this down along with us. And you guys, we're practicing. Test day's coming up. Well, we notice something cancels. So our problem reduces, that big ugly problem reduces down to this. This is where I'm going to focus my attention now. The fact that I canceled means I will have a hole in my picture. The only way we can have a hole is if something cancels out of the original problem. Well, something canceled. So I'm going to have a hole. The hole is where the dot would be if you were graphing this on the number line. So if you were putting it on the number line, the dot would be at negative 2. So your hole is going to be where x is negative 2. Remember, the hole goes at the x coordinate that's the opposite of the thing you canceled. So you canceled x plus 2. We're going to have a hole where x is negative 2. Now we'll take that negative 2 and we'll plug it in right here in the box. Remember, this is where we're looking right now. This is where we're focused. So we're going to take negative 2 and we're going to plug it in. So what do we get? If we plug in negative 2, we get negative 2 minus 3 over negative 2 minus 2, we get 5/4. So we have a hole. We're going to plot it on our grid. We have a hole at the point negative 2, 5/4. So we're going to plot an open circle. That's a hole at that point. All right, now what else do we need? Well, we need all the normal stuff. We need our asymptotes. So where is our vertical asymptote? Our vertical asymptote is wherever the denominator is 0. So your vertical asymptote is going to be where x equals 2. Your vertical asymptote is where x equals 2. Your horizontal asymptote, remember that's when we look at x over x. So x over x is 1. So my horizontal asymptote is at y equals 1. Now I need my intercepts. Remember, your intercepts are points, and they are points where x is 0 or y is 0. One at a time. You do one at a time. So if we let x be 0, if we put 0 in for the x's and let x be 0, we get negative 3 over negative 2, which is 3 halves. So I'm going to plot the point 0, 3 halves. If x is 0, I plug it in, and y turns out to be 3 halves. Now, what about my x-intercept? Well, those are the ones, remember. You guys make it harder sometimes than it is. It's very simple. We're going to let y be 0. And when you let y be 0, to solve that, you're going to bring your denominator over here. But since that's 0, it stays 0. And you end up solving the numerator. X minus 3 equals 0, so x must equal 3. So we have our vertical asymptote, x equal -2, our horizontal asymptote, y equals 1, our whole, our y-intercept at 0, 3/2, and our x-intercept at 3, 0. You have now filled in all the dots. Now it's a matter of filling in the picture. What is the picture going to look like? Well, we've done enough of these, you know, up here. We're going to connect these points. We're going to have a nice little shape like this. And remember, when you draw it, you want your curve to be getting closer to the asymptote. As it goes up and out, we're going to get closer to the asymptote. And this one looks like that. Remember, on the test, we're not going to have anything tricky. It's going to be just a standard little reciprocal function type thing where you have a branch of the curve in opposite corners. So on this particular problem, they're here. In another problem, they could be here, but they're going to be in opposite corners every time. Page 1, done. Awesome. Let's go to the back. Here we go. Now we're going to solve. Now, please pay attention to this. Look at the 3 problems on this page. They're all inequalities. So what do I do with inequalities? Remember, Ms. Ford's got 2 rules for you with inequalities. First of all, what? We got to have them equal to 0. So if they don't already have a 0, we're going to get a 0. And what's the second thing? Draw a number line. Draw a number line. We're not doing any more drawing with asymptotes and all that stuff, but we're going to have a number line for every one of these problems. So here we go. A. Ms. Ford said you got to have a 0. Move the 0 over. Okay, you guys need to be writing this down because I'm going to grade it. No reason for it not to have a perfect paper. Okay, now we're going to factor, just like we did in the last problem. This one's a little different, though. There really are only 2 terms. So we'll just take out an x. We'll just take out an x. That's about all we can do with that. Now, here's my number line. And on my number line, I'm going to put 2 dots. Where do you think those dots are going to be? If you think those dots are at 0 and 6, you are exactly right. The dots are at 0 and 6. Everybody out here knows, should these dots be open or closed? Closed. Very good. These dots are going to be closed. And why are they closed? Because we have an or equal to. And whenever we have an or equal to, our dots are closed. All right, what do we do now? Oh, well, now is when we pick a number, and we can pick any number we want except 0 or 6. You cannot pick 0 or 6. So I don't know what number you want to pick. How about 1? Let's try 1. 1 is in here. If I put 1 into my problem, I get 1 times -5. Now, what's 1 times -5? -5. Is -5 bigger than 0? No. So that did not work. The number I picked, 1, did not work because I needed to pick a number that was bigger, that made my answer bigger than 0. The fact that that section of the number line didn't work means this one does and this one does. They alternate. So I have works, not works, works. I picked a number in here, it didn't work. That automatically means these will. And my answer is everything from -infinity to 0 or everything from 6 to infinity. Remember when you use interval notation that the infinities are always parentheses and the dots are brackets if they're filled in and parentheses if they're open. So 0 and 6 are going to have brackets because those are solid dots. Awesome. What's wrong with this? It does not, it's not equal to 0. So the first thing I have to do is make it equal to 0. So I'm going to move that 6 over. The 6 is going to get moved over. Now you know what has to happen. We've got a couple of things subtracted. And in order to subtract them, since they involve fractions, we need a common denominator. So I'm going to multiply this one by x plus 3 over x plus 3, so that I now have the same denominator. I have x plus 3 for both fractions. Now look at my numerators. I have x minus 2 here, of course, haven't changed that one. Be very careful here. What's this numerator? Negative 6x minus 18. Please don't forget to distribute accurately. Negative 6x minus 18. All right, cleaning up, we have negative 5x minus 20. If I collect like terms, everybody knows how to do that. Algebra 1, you know how to collect like terms. Negative 5x minus 20. Now I'm going to put 2 dots on my number line, just like I did in the last problem. Anybody want to take a wild guess where those 2 dots would be? One of them would be at negative 3. The other one won't be at 0 this time. The other one is going to be whatever makes this 0. So negative 5x minus 20 equals 0. Whatever makes that equal 0 is where the dot's going to go. So it looks like that dot's going to be at negative 4. So I have a dot at negative 4 and a dot at negative 3. The negative 3 dot comes from the denominator, and the negative 4 dot comes from the numerator.
You mean positive 3?
No, because remember how I set that equal to 0? I'm going to set that equal to 0. And when I set it equal to 0, see what happens? It turns into negative 3. It's always the opposite. Always the opposite. This one was positive 6. Always the opposite. Now, here's the tricky part. You guys remember this. You know, because we've talked about it lots of times. Denominator dots, dots that come out of the denominator, can never, ever be equal to. Because you can't have a denominator that equals 0. So even though that's an or equal to in the problem, the only dot that's going to get colored in is the one that comes out of the numerator. Denominator dots are never, ever colored in, no matter what. Now I'm going to pick a number. Any number I want. I like 0. I'm going to pick 0. Now remember, 0's out here. This is where 0 would be on the number line. I'm going to try that number. I'm going to put it in right here, 0. When I put in 0, I get negative 20 over 3. Is negative 20 over 3 less than 0? Yes. So this time, the number I picked worked. So I'm going to color in that end of the number line. 0 worked. That number worked. So I'm going to color it in. Now remember, if that one works, this one won't, and this one will. So my answer is negative infinity to negative 4, or negative 3 to infinity. Remember, if I do something too fast, you can stop and rewind, or just stop and ask your neighbor. for a little bit of help. All right, here we go. Next. This one is tricky. This is a tricky problem. What makes this problem tricky is that right there. So what do we remember about problems that have a squared on one of the factors? We remember that when we get our dots on our number line, we're not going to be able to do that alternating thing. We're going to have to check every space on the number line. So here we go. First part's easy. You guys out here in the audience, where are the dots going to go? Think about what we talked about. Where are these dots going to go? There are going to be 2 of them. Where are they going to go? -4 and +1. They go with the opposite. The opposite, 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 opposite. So we're going to put one at -4 and one at 1. Take a look at that right there. These going to be open dots or closed dots? Those are going to be closed dots. I'm not worried about what I was worried about over here because it's not a denominator. I only worry when it's a denominator. There's no denominators. Now I'm going to pick a number here and here and here. I'm going to have to do this 3 times because of that stupid squared right there. I'm going to have to pick a number here, here, and here. So what would be an example of a number out here? Any number out here, what would be an example? -6. So I'm going to put -6 in. What is -6 plus 4? Squared? 4. So I get 4. Put -6 minus 7. What's that? Oh, -6 minus 1. It is -7. So I got -28. Is -28 less than 0? So that works. I shade that in. Now I got to pick a number here. What's the number in between -4 and 0?
-1.
-1. There's lots of them. Just pick one. -1's fine. What's -1 plus 4? 3 squared. 9. What is -1 minus 1? -2. Now when I multiply 9 times -2, does that come out less than 0? Oh, that works also. Now pick a number out here, any number out here. 5. 5 plus 4 is 9, squared is 81. What do we pick, 5? 5 minus 1 is 4. I don't know what 81 times 4 is, it's a big number. Is it less than 0? No. So that part didn't work. So what parts did I end up shading in? I shaded everything from 1 down, didn't I? I did it in chunks, but everything from 1 down is shaded. From -infinity, that's out here, all the way up to 1 is shaded. Okay, problem D. Another inequality. Now, this is going to be more complicated than the other ones. But since we learned the material earlier in chapter 2, we're not going to have an issue with this. First thing, notice I moved that 15 over, so I had my 0. In an inequality, I want to have a 0. Now I got to figure out, here's my number line. I got to figure out where my dots are going to be. And by golly, I know I'm going to have 3 of them. I know I'm going to have 3 dots because this is an x cubed problem. My issue is I got to get this thing factored. And if you're thinking factoring by grouping, you are so awesome. Unfortunately, it's not going to group. So we need a backup plan. What's our backup plan? If you said PRRs, you're exactly right. We are going to guess and divide. So I'm going to take a quick look at that and see if I can see one quickly. -1. -1 works. You paying attention? This is good stuff. -1 works. So I'm going to divide -1 out. You guys should be writing this down, even if you have no idea what I'm doing, which is fine. You guys better know what I'm doing, but these guys out here might not know what I'm doing. But we're going to divide. We're going to take out that -1. And sure enough, it gives us a remainder of 0. And what I have left is x squared plus 8x plus 15. So how does that factor? X squared plus 8x plus 15. How does that factor? X plus 5x plus 3. And at this point, you're thinking, whoa, 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 I'm supposed to have 3 parentheses because I'm supposed to have 3 dots because it's an x cubed problem. Where is that third parentheses? Right here. Right here it is. So that third parentheses is x plus 1. Remember, it's always the opposite. It's always the opposite. So I'm going to have a dot at -5, at -3, and at -1. Be sure you get those dots, -5, -3, -1, in the right order on the number line. Here is our factored problem. Oops. There's our factored problem. Now we are going to test a number, any number anywhere. What number do you want to pick? Somebody pick a number. Any number except the one circled there. What number?
-2.
-2. -2 is right here. Everybody okay with that? So I'm going to put -2 in. So -2, putting in -2, I would get 3 times 1 times -1. If I put -2 in all these parentheses, what's 3 times 1 times -1? -3. Is that less than 0? Oh, it worked. So this section of the number line works. Which means this section won't, this section won't, but this section will. Remember, they alternate. As long as there's no squares, any of those weird squares in the problem, they're going to alternate. So we picked a number, you guys picked a number right here, and it worked. That means that doesn't, but that does. So in the answer blank, you will say everything from -infinity to -5. Uh-oh, I forgot something.
Yeah, I did.
The dot should be colored in. So everything from -infinity to -5 or -3 to -1. That's what we end up coloring in. Wow. Big problem. All right, now we're switching gears, got a little easier stuff going on now. We're going to solve this equation. Please, 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 no number line, no shading, no dots, none of that. It's an equals. What's the common denominator between 5x and 10? 10x. Your common denominator is 10x. So we are going to multiply everything by 10x. Kids, it only takes a minute, 30 seconds at the most. Write down 10x and every fraction. And now we're going to cancel. 5 goes into 10 twice. X wipes out the x. 10 goes into 10, period. What is left? Now you have canceled every single denominator. So you are left with what? 9 times 2x. 18x plus 3 times 10 equals 7 times x. I'm going to subtract 18x from both sides. So 30 equals negative 11x, and x equals negative 30 elevenths. You may not like that answer, but that's just what it is. That's the answer to the problem. Negative 30 elevenths. Now we have one more of those. It's exactly the same sort of thing, but it is harder. I shouldn't say harder. It is more complicated. It has more stuff in it. And the first thing I'm going to do is the first thing I've done in every problem I've looked at. If it factors, I factor it. So that denominator, that last denominator, that big denominator in that end fraction does factor. So I'm going to factor it. So it would be 2x and x. And almost always, you guys remember this too when you get to this, almost always if you have a problem like this, it's going to factor into these two guys. Not always, but almost always. They're rigged that way. So now I'm going to do exactly what I did in this problem. In this problem, I multiplied by 10x. In this problem, I'm going to multiply by x plus 1 and 2x minus 3. I'm going to multiply by both my denominators so that I can hopefully cancel them out. So I'm going to multiply every single fraction by x plus 1 and 2x minus 3. I graded your quizzes, and those of you that actually write it down usually get it right. Those of you that don't take the time to write it down because you're too lazy, you end up missing it, doing something stupid. So just take a minute and write it down. When you write it down, you can see gone, gone, gone. All the denominators are gone. All you have left is a little bit in the numerator. What's left right here? 4x plus 4. Don't forget to do your distributive. 4x plus 4. Plus, more distributive, 2x squared minus 3x. X times 2x minus 3. Equals, over here nothing's left but negative 8x. Everything else canceled out. Now, everybody in this room, everybody out there, has seen a quadratic equation before. This is 2x squared, I'm going to collect like terms, plus x plus 4 equals negative 8x. What do we do with quadratic equations? There are equations with squares in them. We always get them set equal to 0. So 2x squared plus 9x plus 4. And then we factor them, if they factor. And this one factors. I'm foiling in my head because that's what factoring is. It's unfoiling. See how if I FOIL that, I get 8x plus 1x. So now I'm going to set those equal to 0. So 2x plus 1 equals 0, and x plus 4 equals 0. And my answers are negative 1/2 and negative 4. Sometimes when we do this, we get extraneous roots. Is there anything wrong with negative 1/2 and negative 4? Would they give me zeros in my denominator? No, they would not. So we are good to go. Good to go. All right, one more page. Let's see what we got on the back. Oh, we have our word problems. Just 2 of them though, so that should be pretty easy. Here we go, gang. We're going to do these last 2 problems, and this practice test will be complete. Okay, so the first problem, looking at part 3A, it's a mixture problem. So we know that our formula for mixtures is amount times percent plus amount times percent equals amount times percent. So let's fill in our percentages. Hang in there, peeps. We're almost done. We're almost done with practice test 1. Then we get to do practice test 2. So how much? 9%, 0.09, mixed with 3%, that's 0.03. Don't forget the 0.03. And I want 15 gallons of 0.05. So my percentages, I'm mixing a 9, a 3, and going to end up with a 5. Now the only number they give me in terms of an amount, the only thing they give me is 15 gallons of 5%. So I'm going to put 15 right here. 15 gallons of 5%. Now it says how much 9%. So I'm going to call that X. X is going to be the amount of 9% because it says how much 9%. This is missing. Remember, when that one is missing, it's 15 minus X. 15 minus X. If this one were missing, it would be 15 plus X. All together, I have 15 gallons. If I have X here, I have 15 minus X here. So now I'm ready to do my arithmetic. 0.09x plus 15 times 0.03, 0.45 minus 0.03x. I have to distribute here. So there we go. I've done my arithmetic using my calculator to help me. Now I'll collect like terms. I'll subtract 0.45, and X equals 5 gallons, if I divide it right. Yeah. Okay, amount times percent plus amount times percent equals amount times percent. One more, and this one is a work problem. So 1 over alone plus 1 over alone equals 1 over together. So here we go. Let's see what we can fill in. Will and Zane are painting a fence. It takes Will 15 hours alone. So Will is 15 hours alone. How long does it take Zane alone? So we'll let X be Zane's time alone. 1 over each kid's time alone adds up to 1 over their time together. And what's their time together? 12. It tells us in the problem that their time together would be 12. In a mixture problem, it would be exactly what you're talking about if I were doing this. But in this problem, they tell me that Will is 15 by himself, Zane and Will together are 12, and we're figuring out what Zane is by himself. We had a problem that looked just like this a while ago. The problem that looks just like this was number 2E. Looked just like this. Anybody remember what we did? We multiplied. What am I going to multiply by? Something that's going to cancel out 15, 12, and x. So what will cancel out 15, 12, and x? Well, there are lots of numbers. The smallest one is 60, x, because I have to cancel out that x too. That's the smallest one. Remember, we talked about before that you are allowed to multiply by whatever, anything that will cancel out 15, 12, and x. So 180 would cancel them out. Lots of things would cancel them out. The smallest one is 60, so I'll use 60. 15 goes into 64 times, so I have 4x plus 60. 12 goes into 65 times, 5x. So if I do my canceling, I lose all the denominators, which was the plan, that was the goal. And now I can subtract 4x from both sides, and poor Zane, it takes him 60 hours to do the job by himself. 60 hours to do the job by himself. And that is practice test 1. Good job.